Hello and welcome to my math companion. In this video, we'll be looking at the AND keyword and how it translates to a mathematical operation. So let's begin. Now before I start with the problem, I would like to come back to something that I said in the previous video, and I had left the viewers with a certain scenario of where you're buying t-shirts in a shop with your mom, and I had asked you what would happen to the probability of your mom buying t-shirts if you asked her to buy two t-shirts. So if you were given a choice of five different t-shirts and you asked her to buy the blue one and the green one, would it be higher or lower? Would the probability of your mom buying the t-shirt for you be higher or lower than the probability of her just buying one t-shirt? And if you think of it from a logical sense, you will find out that the probability will be lower than when she would only be buying a single t-shirt. So now this is the same question as in the previous video, but the same information, but the question has changed. So I'll just go over the question quickly. The question says that there are 4 cookies, 7 candies, and 5 chocolates in a jar. And John takes out an item from the jar, puts it back in, and then takes out another item from the jar. What is the probability that the first item is a candy and the second item is a chocolate? So now we're dealing with this and keyword right over here. And as you may have guessed, the and keyword signifies multiplication of two probabilities. Since in the previous video I had stated that multiplying two fractions between 0 and 1, if you multiply them together, it will give you a fraction that is lower than each one of those single fractions. And here we see that the probability of both events happening together is lesser than each one of those events happening independently. So that is why we use multiplication. And now you may ask, why not division? Now, division of two fractions does not necessarily mean that the resulting fraction will be lower than the individual fractions. Because if your starting fraction, if one of your fractions is greater than the other one, then your final answer may be even greater than both of those, than one of those individual fractions. So multiplication is used in the AND keyword. And this question deals with something called with replacement. So as you can see, John has taken out an item and put it back in the jar. And this ensures that our sample space does not change. It will not change throughout the entire course of the problem. And that happens when you have a with replacement question. And these are quite recurring questions in probability, quite common questions in probability. So you will not the question will not always say that John takes out an item and puts it back. It may just say with replacement. So that's what the words puts it back in signifies, with replacement. And now we'll go back to our sample space. So sample space is again 4 plus 7 plus 5, which is 16, since we have 4 cookies, 7 candies, and 5 chocolates. And our condition is we want a candy and a chocolate. So a candy on the first go and a chocolate on the second time. The second time he takes out an item. So first we'll evaluate for candies. So we know that the number of candies that are there in the jar is 7. So we can calculate the probability of just picking a candy. So we evaluate the individual probabilities of a candy and a chocolate and then multiply those two together. So in a candy, we can say the number of elements satisfying the event, elements from the sample space satisfying the event, divided by the total number of elements in our sample space. So number of elements satisfying the event is this 7, and the total number of elements is 16. So the probability of picking a candy is just 7 over 16. Now we'll do the same for a chocolate. So the number of elements satisfying the event is 5, since we have 5 chocolates from here, 5 chocolates, and total number of elements remains the same. It remains the same. Our sample space will not change. So the total number of elements is still 16 And now we just have to multiply them together. 5 divided by 16 times 7 divided by 16, and that gives us 35 upon 256. This is the most simplified form of our final fraction. So that is how you interpret an AND keyword in a probability question. It 99% of the time signifies multiplication of two different probabilities. I hope you enjoyed this video. Do join us in the next video where we'll be looking at without replacement questions involving the AND keyword in probability.